So continuing note 6-1, square roots as inverses, I want you to use function composition to prove that f of x equals x squared plus 7, where x is greater than or equal to 0, and g of x equals square root of x minus 7 are inverse functions. So I want you to remember function composition means you're doing f of g of x, and you want that to equal x, and you also want g of f of x to equal x. In order for the two functions to be inverses, that's what needs to happen. So if I'm looking at f of g of x, that means I'm taking g of x and I'm plugging it into f. So I'm taking this here and I'm plugging it in where I see x here. So that means I'm plugging in square root of x minus 7 and then squared plus 7. So what you should see happen is it should kind of unfold. So looking at this, the square and the square root are going to cancel out. So you've got x minus 7 plus 7. And then the minus 7 and plus 7 go away. You've got x. Yay. So f of g of x equals x. So far so good. Now let's see if g of f of x equals x. So if I plug in f in here where I see g, so that means I'm plugging in x squared plus 7 where I see x, and then minus 7. So in here what happens is the plus 7 and the minus 7 cancel. So you've got square root of x squared. The plus 7 and the minus 7 cancel. So remember here, technically you've got square root of x squared, which should be plus or minus x. But the reason we only have positive x and not minus x is because it says x is greater than or equal to 0. So you can't have plus or minus because it's got to be greater than or equal to 0. So g of f of x also equals x. So therefore, f of x and therefore, that's what that means. Therefore, f of x and g of x are inverses. Yay. Okay, so moving right along. Use function composition to decide if f of x equals x squared minus 1, where x is greater than or equal to 0, and g of x equals square root of x plus 1 are inverses or not, or inverse functions. So if I go to find f of g of x, that means I'm plugging in g where I see f. So here this needs to go in where I see x here. So that would mean I've got square root x plus 1 and then squared and then minus 1. This is already kind of turning out to be pretty ugly because here I can't just say the square root and the square cancel out because this whole thing isn't in a square root. So in this case, this means I've got two of these, x, square root of x plus 1, square root of x plus 1. So here I've got square root of x times square root of x. Well, that's going to be square root of x squared when I'm foiling. This times this would just be square root of x. This times this would be square root of x. And then 1 times 1 would be 1, and then minus 1. Well, yeah, sure, those cancel out, and then this becomes x. But then a square root of x plus a square root of x is actually going to be 2 square roots of x. So this does not work. Okay, so no, that's a no-go. F of x and g of x are not inverses because it did not equal x. I don't even have to go any further.